First, let me discuss to you the principle of source transformation. Source transformation is simplifying a circuit solution, especially with mixed sources, by transforming a voltage into a current source and vice versa. Finding a solution to a circuit can be difficult without using methods such as these in order to make the circuit appear simpler. Performing a source transformation consists of using Ohm's law to take an existing voltage source in series with the resistance. And replace it with a current source that is in parallel with the same resistance. Remember that Ohm's law states that a voltage on a material is equal to the material's resistance times the amount of current through it. Since source transformations are bilateral, one can be derived from the other.
So, for better understanding, I will show you another example. So, example, consider the circuit shown in figure 1. Find the value of Vx, that is the voltage across 12 ohms. So, by using Ohm's law, that is I is equal to V over R, our voltage here is 4, and resistance is 6. Therefore, I is equal to 2 over 3 ampere. Since we have this sign convention, therefore, the current should be directed downward. So here is the simplified circuit. We have a current source that is directed downward, 2 over 3 ampere, parallel 6 ohms, and ohms. Just copy the circuit. So, we can notice that 6 ohms and 12 ohms are in parallel. Therefore, simplifying this resistance will give us 6 times 12 is 72 over 6 plus 12 is 80. Therefore, our R is 4 ohms. So, redrawing the circuit, we have 4 ohms, 2 over 3 ampere, 8 volts, and the 2 ampere source. So, applying the source transformation, again, V is equal to IR. Our current here is 2 over 3 and resistance is 4. Therefore, V is equal to 8 over 3 voltage. So, since we have this sign convention, therefore, the positive polarity of voltage should be like this. Simplifying the two voltages here, we have negative 8 over 3 volts minus 8 volts. And we get negative 32 over 3 volts. Drawing the circuit, applying again the source transformation here, we have I is equals to 32 over 3 volts divided by 4, and that is equal to 8 over 3 ampere. So redrawing the circuit again, we have so since the polarity is the positive, therefore the current should be directed downward. Simplifying the two sources, drawing the circuit, we have 2 over 3 ampere that is directed downward with a parallel of 4 ohms and 12 ohms. Applying the transformation again here, we have V is equal to 8 over 3. Drawing the circuit, and to get Vx, we use the voltage divider law. Vx is equal to 8 over 3 times 12 over 4 plus 12. Vx is equal to 32 over 16. Vx is equals to 2 volts. So as we noticed, the polarity of the voltage source is opposite to that of Vx. Therefore, our final answer should be Vx is equal to negative 2 volts.
Example of AC source transformation. Given the circuit shown, find Vx. Using Ohm's law, we'll transform the voltage source into current source by dividing 5 ohms to 20 angle negative 90 degrees volts, where the omega is equal to 1000 rad per second. I is equal to V over R. 20 angle negative 90 degree volts, we can simply write this as negative 20J. Substituting the values, we have negative 20J over 5 ohms. We have I1 is equal to negative 4J amperes. Next, to determine the reactance of the inductor, we have XL is equal to JWL. Substituting the values, we have 4J ohms. Next, to determine the reactance at capacitor, we have 1 over GWC. Substituting the values, we'll get negative 13 J ohms. Redrawing the circuit, we have the new current source, negative 4J amperes, making it parallel to the same resistor 5 ohms, an impedance of 3 plus 4J ohms, 4 minus 13J ohms, and 10 ohms.
We know that 5 ohms is parallel to 3 plus 4J. Simplifying this, we have 2.5 plus 1.25 J ohms. Again, rewriting the circuit, we have negative 4J ampere in parallel to the new impedance of 2.5 plus 1.25 J ohms and an impedance of 4 minus 13 J ohms and 10 ohms. Next is as applying source transformation to negative 4J ampere and new impedance, we have V is equal to IR. Negative 4J times 2.5 plus 1.25 J ohms, we have our new voltage source of 5 minus 10 J volts. Redrawing the circuit, we have our new voltage source of 5 minus 10 J volts in series with the same impedance of 2.5 plus 1.25 J ohms, an impedance of 4 minus 13 J ohms, and 10 ohms. As you can notice from the very beginning, we did not take any action to 10 ohms because this is where our Vx lies. So, simplifying the two impedances will yield us to 6.5 minus 11.75 J ohms. Again, for the very last time, withdrawing the circuit, we have a voltage source of 5 minus 10 J volts, a new impedance of 6.5 minus 11.75 J ohms, and the 10 ohms. So, in order for us to get Vx, we use the voltage divider theorem. So, 5 minus 10 J volts times 10 over 6.5 minus 11.75 J ohms plus 10 ohms. This will yield us to 5.52 angle negative 28 degree volts in polar form.